So we have one more step to perform before we're happy, and that is that we've taken our tools, we've touched them off, we've adjusted from our indicator plane to our workpiece height. One thing that we really want to make sure of is that we have done this properly. So right now we're just hoping that we've done it right. Now we're going to verify that we actually have done this procedure correct. The way we're going to do that is we're going to input individual commands into our NC controller and have the machine automatically pick up and read our tool length offsets. So in order to do that, the first thing I'm going to do is I'm going to remove the indicator from my table. We shouldn't need that anymore. And I'm going to put my very first tool back into the spindle. So I believe it was tool 6. So to do my tool change, I'm going to go T6, cycle start. And the machine will go through the process of grabbing that tool for me. So we'll wait until it says T6 on our control panel. And I personally, when we verify our tool heights, because we're going to have the machine moving automatically, I like to perform my verification in the tool change position. You'll see that when we perform a tool change, the table moves way out of the way, and it also comes all the way towards us. I like to do my verification over here because if we have done something wrong, and it's bound to happen, and that's totally fine. Again, we are learning, but if something does not go correct, and this tool goes way, 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 way below the surface of my vise of my workpiece, I will know that something isn't right. I will have time to hit my E-stop. Whereas if we verify directly over top of our workpiece, we don't have that same time because we're watching to see where it's going to stop. Whereas when our tool starts getting low over here, we know that something's not right. We can just stop it right away. So in order to get the machine to perform automatic operations, we're going to use ISO mode. ISO on other machines, a lot of times it's referred to as MDI, which is manual data input. This is what we're going to use to perform those small commands. So this will be the machine automatically reading the information that we have given to it, and it will be performing and moving to those said locations. So the first thing that we need to do, and we only need to do it once, is we need to tell the machine which fixture offset we are using. So in our very last step, we adjusted our G54 Z axis from our indicator plane to the top surface of our workpiece, and we used our G54 fixture offset. So the first thing that we're going to do is we're going to press ISO mode, and you're going to see this dialog box appears at the bottom of my screen, and in that I'm going to type G54. Now we don't need to adjust our feed rate down. There is no movement command with this G54. Just out of my personal habits, I like to adjust my feed rate so that it is below 50% when we are doing any rapiding movements, especially when we're verifying, because we don't want to see the tool moving at full speed. So with G54, I'm going to hit cycle start, and nothing has moved in my machine, which is wonderful. That's what we wanted. But you may have seen my numbers here have changed. The reason my bigger numbers have changed is because these are reference numbers, and it's now locating off of wherever my G54 X, Y, and Z axis are being based from. The next thing that we want to do is we have tool 6 in our spindle. We need to read the height offset for tool 6 and move the tool into our proper position. So again, we want to press ISO. So we want our tool to move. We don't want to be feeding. We do want to do this really quickly. So we want to rapid into position. So rapid is a G00. We also want to be basing our tool movements off of a fixed position. We don't want to base our movements from where we are, where our tool currently is. we want to base it from a set location that we have given in our fixture offset. So we want to be in absolute mode. So being in absolute mode, we want to type in a G90. And the very next thing that we want to do is we want to read our tool length offset. So this command only comes on our command line when we are moving our Z axis for the first time. So our tool length compensation is G43. I often refer to this as read tool length offset, because really what we're doing is we're telling the machine to read our height offset and move to a Z position. So the Z position we're going to move to is not going to be Z0, even though we want to base our movements off of the top surface of our workpiece. Again, we don't want to bring our tool directly on top of our workpiece. I always like to stay a safe distance above, and I find that 2 inches is best. So I'm going to type in Z 2.0. Obviously this is going to be a positive number because I want to be above the height of my workpiece by 2 inches. And we have one more piece of the puzzle that we need to input, and that is, what height offset are we reading? Well, that's really easy to know. We are using tool number 6. We want height offset number 6. In order to read the height offset with Fagor controllers, it is a D value. So because we're using T6, we want D06. Now I should be able to hit cycle start, and we're going to rapid in absolute. Then we're going to read our height offset, come 2 inches above our workpiece, with tool height offset number 6 being read. So I'm going to hit cycle start, and you will see that my tool is moving down, and it may not look like it, but I am prepared to like run over and hit the E-stop in case it moves too fast, or in case my tool moves down too far. So right now, when I look at my screen, you can see it says that we are 2 inches above the top surface of my workpiece. So what I'm going to do is I'm going to move, using my pendant, I'm going to move my X-axis and bring my tool over top of my workpiece. So I'm going to move my X, then I'm going to move my Y. And now I need to measure to find out, because we've told it to come 2 inches above. The machine is saying, hey, this is where we think your tool should be if it's 2 inches above your workpiece. Now we're actually going to check to make sure our tool is 2 inches above our workpiece. And we're going to do that by using a 1, 2, 3 block. So this is called a 1, 2, 3 block. It's not a very creative name. It's because when we measure this surface, it's 1 inch. When we measure these surfaces, it's 2 inch. And when we measure these surfaces, it's 3 inches. So we already have a really good indication of whether or not our tool will actually be 2 inches above our workpiece. So what I'm going to do is I'm going to set my 1, 2, 3 block on the surface of my workpiece. I'm going to move my pendant to be in times 10, so I'm only moving 1 thou at a time, and I'm also going to move it to the Z location. I'm now going to slide my 1, 2, 3 block, and you're going to see that my 1, 2, 3 block slides underneath really, really easily. Now I'm going to adjust my pendant, so I'm moving down 1 thou, and you can see on my controller now I'm no longer at 2 inches, I'm at 1.99, and I'm going to check to see if the drill is touching my 1, 2, 3 block, and it's not. I'm going to continue moving my Z-axis down, and you'll see I've moved 2 thou, it's still sliding underneath, 3 thou, and there we go there, 4 thou. 4 thou is like if we took 2 pieces of hair and put them on top of one another. That's really the distance that we are off with this tool from the top surface of my workpiece. I'm not going to worry about 4 thou. If we started getting, into the 10 thou difference between where our tool thinks we're at 2 inches and where we actually are at 2 inches, then, I would say we need to make some changes, and it would either be from, whether we touched off on our indicator and our probe wasn't working correctly, or maybe we just put in a bad tool length offset. Those are some of the common practices that would cause errors here. Again, for 4 thou, I'm not really going to lose much sleep over that, especially with just a drilled hole. So now that I've checked this and I've determined, okay, this tool is good, it's really close to where we think we are with 2 inches, I can now bring my tool up, and I want to repeat this process with all my other tools. So this concludes the demonstration on loading tools inside your spindle, taking tool length offsets, work shifting, and then verifying that your tool length offsets are correct. Again, this is just one of the many different ways that you can take tool length offsets. If you have any questions or concerns, please feel free to contact either myself or your practical professor. Best of luck, and hope to see you in the lab.